Hello, I'm John Callas, a physicist at the Jet Propulsion Laboratory and a former project manager for the Mars exploration rovers. I'm also a member of the California Art Club. The arrival of the next rover at Mars, Perseverance, creates an exciting opportunity for artists of all skill levels to help participate in the exploration of Mars by painting landscapes. And we have numerous images already taken by other missions from the surface of Mars that will be wonderful subjects for many of you artists. So I'm here to tell you a little bit about the planet Mars and how we take images from the surface so you can better interpret those landscape images as you work on your own artwork. So this image that you see here is a ground-based telescopic image of Mars. Mars, of course, is one of the planets that's been known to the ancients, but of all the planets in the solar system, it's perhaps the one that is most Earth-like. It has many features that are similar to the Earth, although many differences. In this image, you can see the polar cap of Mars, and those, the northern and southern polar cap, they wax and wane with the seasonal cycles. The planet is tilted on its axis by 25 degrees, very close to the Earth's 23 1/3 degrees. So Mars, like Earth, has 4 distinct seasons. And early astronomers would see the surface features of Mars change with the seasonal cycles. And that even led some to postulate about the existence of life on Mars. But it wasn't until the dawn of the space program that we got our first close-up look at Mars. And you can see that in this Viking image taken in the mid-1970s showing the surface of Mars, and no obvious signs of oceans or forests or continents. But what you do see is that Mars has a thin, tenuous atmosphere. The atmosphere is only about 1% as thick as the Earth's atmosphere, and it's 95% carbon dioxide. So if you were on the surface of Mars, you would need a spacesuit. Although the atmosphere is very thin, there is a lot of suspended dust in the atmosphere, which colors the light as seen from the surface of Mars. We have landed on the surface of Mars, first with the Viking missions in the mid-1970s. You can see here the regolith, or the rocks in the near the lander, and you can also see the atmosphere and sort of the butterscotch faded color that appears at this particular location. Not until the 1990s did we return to the surface of Mars with the Mars Pathfinder mission, which carried the Sojourner rover, as you see here. Again, you can see the atmosphere, and that it is, in this case, a muddy colored brown, again, due to the atmospheric dust. But also the fact that the Mars is further from the sun than the Earth. It's about 50% further. And so the surface of Mars only gets about 60% of the sunlight that we get here at Earth. So it's a dimmer illumination environment. And of course, it's very cold and very inhospitable on Mars. But we wanted to really explore Mars in detail, and that was with the Mars exploration rovers. And this was the mission that I worked on for almost 20 years. Here you see the rover with the 6 wheels and solar panels, and you can see the cameras on the top of the mast. And notice the cameras are very much at human height compared to the people working around it. And they're in stereo pairs. So the images that we get back with this rover have very much a human perspective. The cameras have 20/20 vision, and the rover does have depth perception. However, there are limitations to the cameras on these rovers. Typically, the format for each of the detectors is only about 1024 by 1024, in other words, a megapixel, typically significantly less than cameras that you might have in your smartphone or a digital camera you might have at home. However, when we take images, we mosaic them. We take multiple pictures to form panoramas, so we can get very high resolution, large panoramas. But we also take pictures in black and white mostly. And the way we get color images is we take successive images with color filters rotated in front of the camera lens. Some of the cameras on the more recent rovers do have bare filters on their cameras, so they take color images much the way your digital camera does. But these cameras are all limited in their color perception. The human eye has much more capability in picking out the variations of colors, so we spend a lot of time synthesizing the colors that we see in the images. And in general, most of the images that you see are approximate true color of Mars. So the artist will have an advantage to be able to improve on the visual scenes as observed on Mars. The rovers were able to climb hills. Here is Spirit climbing up the Columbia Hills. You can see features in the distance, mountain ranges on the horizon. And if you look carefully in the upper right, you'll see a dust devil, but you'll see it twice in two different colors. And this illustrates how we take color images. We take successive images with different color filters. Of course, this dust devil moved in between. We took those particular images. So each of those dust devils is missing one of the three colors to make it a full color image. And so it appears either pink or green as it moved around. This is a close-up image taken by Spirit of some soil that the rover disturbed. You see in front of you is the robotic arm of the rover as it was examining that soil. But this one is of particular interest because look at the variation in colors and textures of the surface material. As we broke through this crusty material and revealed this fine multicolored mineral deposits here, ranging from white over the right and yellow, all the way to purple and dark red and brown. So a wonderful palette of colors on the surface. We often had to park the rovers during the winter time and tilt their solar panels by tilting the rover on a slope to generate energy. But here we're on the edge of Endeavour Crater. You can look across this 20-kilometer or 12-mile diameter crater to the far rim on the other side. You can see some of the hazy colors. This image has its colors stretched to bring out some of the geologic features. So it's not true color. We sometimes refer to it as approximate true color. You can also see some of the dust on the solar rays of the rover itself. Here, the rover has been climbing up the rim of the crater, and you can follow the rover wheel tracks as they disappear down towards the center left of the image and get an appreciation for how far this rover has traveled. And here we're actually up at the highest point along the rim. We raise the flag. We have the small decorative flag on the end of the robotic arm you can see there. But you can look across to the far rim of the crater and you can see this hazy blue color. Again, this is a false color or a stretch color. So the haze is not really this teal blue. Again, we'll probably be closer to a pinkish red, but we did this to be able to bring out the presence of that haze that's settled into the bowl of the crater. And then here is sunset on Mars taken by Spirit. We're further away from the sun, so the sun is smaller. But like the Earth, we get rich colors in the sky, but here the colors are reversed. On the Earth, we have a blue sky and typically pink and red colors for the sunset. But here on Mars, the sky is pink and the sunset colors are blue. And again, this has to do with not only the thin atmosphere, but a lot of the suspended dust in the atmosphere that changes the color palette. Here is a panorama by Curiosity, and this is very reminiscent of perhaps somewhere in the desert southwest of the United States. The geology on Mars is very similar to the geology on Earth. There's no apparent liquid water on the surface of Mars today, although we have confidence that there was water one time in the ancient past. So today Mars is very desert-like, with lots of rocks and soil, much like you would see in the desert here on the Earth today. But the next rover, Perseverance, is on its way to Mars. It was launched in July, and it will arrive on Mars on February 18th. So this is the exciting opportunity that's motivating us to create this timely opportunity for artists to paint Martian landscapes. This rover carries a helicopter with it. This is the helicopter Ingenuity, and this will take flight on Mars, and this will be the first time that any human activity has taken flight on another world. This will be our Kitty Hawk moment for Mars, and this helicopter carries a set of cameras too, and will also produce images for Mars, which will be very dramatic and very exciting. So I hope you will take this opportunity to paint your favorite image of Mars, and you can find these at this particular website. There are many websites, in fact, but photojournal.jpl.nasa.gov is where you can find publicly released images that are captioned and in multiple resolutions for all the objects in our solar system, but you can do a search on Mars or do a search by mission to find the surface landscape images that you would like to paint. I hope you found this video helpful in the preparation of your own artwork. and I look forward to seeing your submissions